Geotechnical engineering. Welcome to Blueprint to Reality, the channel where we bring complex civil and structural engineering concepts to life. Here, we explore the fascinating world of engineering, from understanding the foundations that hold our buildings to the cutting-edge innovations shaping the future of construction. In today's video, we're diving into the field of geotechnical engineering, an essential discipline that deals with the very ground beneath our feet. Introduction to geotechnical engineering. Geotechnical engineering is a specialized field within civil engineering that focuses on studying earth materials such as soil, rock, and groundwater. It involves understanding the physical and mechanical properties of these materials to design foundations, retaining walls, and other structures that interact with the ground. This branch of engineering is crucial for ensuring the safety, stability, and longevity of construction projects. Understanding earth materials. Earth materials like soil and rock are complex and highly variable. Each type of soil or rock has unique properties such as strength, compressibility, and permeability. These properties determine how the material reacts to loads, environmental changes, and time. Geotechnical engineers analyze these characteristics to predict how the ground will behave under various conditions, ensuring that construction projects are built on solid, stable ground. Importance of site investigations. Site investigations are one of the foundational steps in geotechnical engineering. Before any construction begins, engineers perform detailed studies of the ground conditions. This involves drilling boreholes to collect soil and rock samples, conducting tests like standard penetration tests, SPT, or cone penetration tests, CPT, using geophysical methods to map underground layers. These investigations provide critical information about the subsurface, helping engineers design structures that can withstand the forces of nature and human use. Designing foundations for stability. The foundation of any structure is its most critical component. Geotechnical engineers are responsible for designing foundations that distribute the load of a structure evenly and prevent settlement or collapse. Depending on the soil conditions and the type of structure, they may choose between shallow foundations like footings or deep foundations such as piles. The goal is always to create a stable interface between the structure and the ground. Solving complex geotechnical problems. Geotechnical engineering isn't just about building, it's also about solving problems. Challenges like landslides, soil liquefaction during earthquakes, and erosion can pose serious risks to infrastructure. Geotechnical engineers use advanced techniques to address these issues, including soil stabilization using chemicals or mechanical methods, constructing retaining walls to prevent landslides, implementing ground improvement techniques like grouting or dynamic compaction. These solutions protect structures and ensure they can withstand natural and man-made hazards. Applications in real-world projects. Geotechnical engineering is the backbone of many large-scale infrastructure projects. From skyscrapers to highways, tunnels, dams, and offshore platforms, geotechnical expertise ensures these projects are feasible and safe. For example, skyscrapers rely on deep foundations to support their immense weight. Roads and highways depend on compacted soil layers for stability. Dams use engineered earth materials to resist water pressure and prevent seepage. Even temporary projects, like excavation for underground parking garages, depend on geotechnical engineers to manage soil and groundwater challenges. The fascinating case of the Leaning Tower of Pisa. The Leaning Tower of Pisa is a classic example of why geotechnical engineering matters. Built on soft, unstable soil, the tower began tilting soon after construction. Modern geotechnical methods, such as soil stabilization and foundation reinforcement, could have prevented this iconic tilt. Today, engineers have used advanced techniques to stabilize the structure, ensuring its preservation for future generations. Conclusion: the role of geotechnical engineering. Geotechnical engineering is an essential field that ensures the safety and stability of our built environment. By understanding the behavior of earth materials and designing structures that work in harmony with the ground, geotechnical engineers protect lives and create infrastructure that lasts. Whether it's a towering skyscraper, a long highway, or a simple retaining wall, geotechnical engineering is the invisible force holding everything together. Thanks for watching Blueprint to Reality. Be sure to subscribe for more deep dives into the world of engineering and architecture. Understanding the life cycle of structural materials. Have you ever thought about what happens to the materials used in construction from the moment they're extracted to the end of a building's life? Understanding the life cycle of structural materials is essential for creating sustainable, durable structures. Let's explore how materials like steel, concrete, and timber serve us across their entire journey. The beginning, extraction and production. The life cycle starts with material extraction. Steel is made from iron ore, mined and processed in energy-intensive furnaces. Concrete relies on limestone, clay, and sand, mixed with water and cement. Timber comes from trees, harvested and treated for construction use. These materials undergo significant processing to become strong, durable, and ready for use in buildings. However, the extraction and production phases often generate high environmental impacts like CO2 emissions and habitat disruption. Engineers are increasingly turning to recycled materials and sustainable alternatives to minimize these effects. The middle, construction and use. Once produced, materials are transported to construction sites and integrated into structures. Here, their performance depends on how they're used. Steel provides strength and flexibility, ideal for high-rises and bridges. Concrete is excellent for foundations, walls, and roads due to its compressive strength. Timber is prized for its versatility and renewable nature, often used in residential construction. During the use phase, materials face everyday stresses like weather, loads, and wear. Engineers carefully design and maintain structures to ensure these materials perform as expected, sometimes for decades or even centuries. The end, deconstruction and recycling. When a structure reaches the end of its life, materials face a critical turning point. Traditionally, they were demolished and sent to landfills. Today, sustainability demands a different approach. Steel is highly recyclable, with scrap often melted down and reused in new projects. Concrete can be crushed into aggregate for new construction. Timber may be repurposed for furniture or bioenergy. This circular approach extends the life cycle of materials, reducing waste and conserving resources. Challenges and innovations. Each material faces unique challenges. Steel production generates significant emissions, but advances like hydrogen-based smelting aim to make it greener. Concrete has a high carbon footprint due to cement, but innovations like carbon-sequestering concrete are changing the game. Timber is renewable but requires careful forestry management to avoid deforestation. Engineers also use life cycle analysis tools to evaluate the environmental impact of materials and choose the most sustainable options for each project. The future of structural materials. The life cycle of structural materials is evolving with technology. Smart materials like self-healing concrete and bioengineered timber promise longer lifespans and lower environmental impact. By understanding and optimizing this life cycle, engineers are paving the way for sustainable, efficient, and resilient construction. Structural materials are more than just building blocks. They're the foundation of sustainable development. By managing their life cycle responsibly, we ensure they serve us and future generations effectively. Thank you for exploring this journey with us. Share your thoughts below, and stay tuned for more insights into the fascinating world of engineering.